Hello, ladies and gentlemen. This is lecture 33 of Math 5700. We are in the middle of section 5.4, which is about the normal random variable, or the so-called normal distribution, which is a bell curve. So let me resume. We will continue and end this section today. Okay, so this is section 5.4, continued. It's about the normal distribution. N of mu sigma squared. And recall that the probability density function of the normal distribution with the parameters mu and sigma squared is given by 1 over sigma times the square root of 2 pi exponential e to the x minus mu squared over 2 sigma. And there are a couple of things about it. The expected value we saw of a random variable, which is normal, with these parameters is given by mu, and the variance of the random variable with this PDF is always given by sigma squared. That's how the parameters relate to the expected value and the variance. And there's another thing we also learned last time. We also learned that that if x is n mu sigma squared, then I can form a new random variable z, which is x minus mu divided by sigma. Then z is normal, and it's of type n0, 1. So its mean is 0, its variance is 1. And the case of z is, the bell curve is actually called the standard bell curve, where the mean is 0, so it's symmetric about the vertical axis. And the cumulative distribution function, if this is a variable z, little lowercase z, the cumulative distribution function is calculating the area to the left. Okay, so what I'm going to do is I'm going to do some examples for the remainder of today, very simple examples on how to calculate. And in order to calculate, there are two ways to do calculations typically. The old way is to use tables, like on page 204 in our text. And the newer way, relatively newer way, which is probably not more than 20 years old, is to use an online calculator. And maybe some of your own personal calculators will do the calculation for you. I believe they do. Okay, so let me get to that. Okay, so here's a simple exercise. Suppose let x be n to 9. So that means mu is 2, sigma is 3. So find the probability that 1 is less than or equal to x is less than or equal to 3. Okay, well, the way to do this is to convert it to a z random variable. You see that z, remember, was x minus, in this case, x minus 2 over 3. So in order to get the inequality for z rather than for x, this would be the same thing as the probability that 1 minus 2 over 3 is less than or equal to z is less than or equal to 3 minus 2 over 3. In other words, the probability that negative a third is less than or equal to z is less than or equal to 1/3. Okay, so now this is now the standard normal random variable, and So what we're looking for is the area of the normal curve that's sandwiched in between 1/3 and minus 1/3. We're interested in this shaded region. Now this is by symmetry. In this case, by symmetry, this is twice the area. Yeah, twice the area of the probability for 0 less than or equal to z is less than or equal to 1/3, because it's completely symmetrical about the vertical axis. And this is going to be the same thing as the probability of everything to the left of 1/3. So, oops, that's no good. But then we have to subtract off everything to the left of 0. Then take that and multiply it by 2. Okay. Now, this number here, everything to the left of 0, is 1/2 the area of the curve. So this number has to be 0.5. So we just have to calculate the probability that z is less than 1/3. And in order to do that, we have to make use of some table. Okay, so I'm going to lose this screen, unfortunately. But let me see what I can do about that. Okay, so what you're looking at here is some web page which has a standard probability of the region to the left of the variable z, and this is computing the table entry. So for example, if I want to look at about 1/3, that's 0.33. Everything to the left of 0.33 is 0.6293 according to the table. So this is one approach to doing this. This is not the very modern, this is the way things were done in the past. And we have some negative numbers here as well. A more modern way to do this is to put in um, this is called Stat Trek. There are a bunch of different online programs that calculate this for you. So I can put 0.3333, this is 1/3, and oops, I didn't do that right. Yeah, so in the first box, we can put in 0.333333, lots of threes, to make 1/3. And now we can calculate the probability, the cumulative probability that z is less than 1/3, and you get 0.631. Okay, so let's remember that number, 0.631. Okay, and so 0.631. And then we go back to, I'll go back to the other screen now. Okay, so I lost my slide, but the probability that x is between 1 and 3 is the same. We saw was the same as twice the probability that z is at most 1/3 minus the probability that z is less than or equal to 0. I've inserted the value 0.631 in here, so I get, what do I get? I get twice 0.131, which is the same thing as 0.262 should be the answer. So that's my answer to this question. Likewise, let's do another problem of this kind. What about the probability? Remember that x is n to 9. So mu is 2, sigma is 3. And what's the probability that the absolute value of x is bigger than 1, strictly bigger than 1? Well, what does it mean to be strictly bigger than 1? This is the probability that x is bigger than 1, or the probability x is less than -1. That's an or. But that's the same thing as the sum of the probabilities that x is bigger than 1 plus the probability that x is less than -1. Now we can actually convert this to a z random variable by subtracting 2 and dividing by 3 both sides of the inequality in each case. So this would be z is bigger than 1 minus 2 over 3. 1 minus 2 over 3 is negative a third, plus the probability of, so if x is less than minus 1, we can take minus 1 minus 2 and divide by 3. You're going to get, so negative 3 over 3. So that z is less than minus 1 minus 2 minus 2. Negative 3 over 3 is negative 1. Okay, so this is what we have to calculate, and we can do that with the StatTrek calculator. I'm going to just do the calculation without erasing the screen, so I'm not going to share you the calculator again. Now, in order to get this in the format necessary for doing the computation on StatTrek, I have to convert the inequality z is greater than minus 1/3 to the complementary probability, which is 1 minus the probability z is less than or equal to minus 1/3, and then I can calculate that. So you get 1 minus, and now what's coming is from the calculator, 0.369 plus 0.159, and what is that equal to? So that's equal to 0.79, so that should be the answer. Okay, so here's another kind of problem, IQ scores. So IQ, it's the way it's set up, the mean is 100 and the standard deviation is always 15. So so this is and it's thought to be a normal, it's a normal random variable. It forms a bell curve, and it's of type N100, therefore 225, because 15 squared is 225. So what is the probability of having an Q score bigger than 110? Well, that's the same thing as the probability of z being bigger than 110 minus 100 over 15, which is the same thing as the probability of z being bigger than 0.6667, 2/3. And that's the same thing as 1 minus the probability that z is less than or equal to 0.6667. And we can look that up on the normal table. So that's 1 minus 0.748, which is about 0.25. Okay, so about a quarter of the population, it's actually 0.2514, that's more accurate. This is about 1/4 of the population has an IQ bigger than 110. Okay, what about an IQ that's bigger than, say, 130? So that gets more interesting. That's the same thing as the probability that z is bigger than 130 minus 100 over 15, which is the same as the probability that z is bigger than 2, which is the same as 1 minus the probability that z is less than or equal to 2. And if you look it up on the calculator or the table, it's 1 minus 0.9772, which is 0.0228. So that's about 2% of the people have an IQ above a score of 130. Okay. Okay, so the last thing I want to do is consider the following kind of question, which is important. So let's let x be a random variable, continuous random variable of type normal of type mu sigma squared. So what is the probability of x being within one standard deviation of the mean? That's the question. So what does this really, what do I mean by this? Well, mu is the mean and sigma is the standard deviation. I'll just write SD for standard deviation. So we're asking is, what is the probability that X is lying between one standard deviation of the mean? That means X is less than or equal to mu plus sigma, but greater than or equal to mu minus sigma. So that's what we're asking here. So now what we can do is convert this to a Z random variable by subtracting sigma from each term in the inequality and subtracting mu and dividing by sigma. So if we subtract mu from mu minus sigma, we get minus sigma, and then divide by sigma, we get -1, as Z is less than 1. Okay? All right, so what is that? What is that giving me? So we're looking at the curve, the standard normal curve. We want to look at the region between -1 and 1. So by symmetry, in this case, that's twice the probability that 0 is less than Z is less than 1, which is twice the probability that Z is less than 1, minus the probability that Z is less than 0, but that's 0.5 we saw before. And the probability that Z is less than 1 is 0.8443. That's from the StatTrek calculator. So if you do the calculation, you'll see that this is 68.68. So 68% of the area is contained between these two numbers. So what I'm saying is that 68% of all points under the normal curve, 68% of those of the region under the normal curve lies within one standard deviation of the mean. So likewise, if we want to do two standard deviations, that's going to be about 0.95. In other words, 95% of the area. And three standard deviations is about 99% of the area. So in terms of IQ, for example, 68% of the population lies within an IQ within an IQ between 85 and 115. 95% of the population has an IQ between 70 and 130. And 99% of the population has an IQ that's 55 between 55 and 145. So which means that the people who have an IQ that's less than 55 or more than 145, they constitute about 1% of the population. And by symmetry, if your IQ is 145 or higher, you're in 0.5% of the population, according to according to the normal curve. Well, I think that's enough for today. Have a good one.